Hello everyone. We are welcome to today's class. So in today's class, we are going to be looking at the topic which is quadratic equations. Under this topic, we are going to be looking at the basic concept of quadratic equation. Then after that, I'm going to give you the examples of quadratic equation. Then thereafter, we are going to be looking at the derivation of quadratic equation from given roots. So these are the objectives of the class. So the first one, the basic concept. So if I say quadratic equation, as you know, we have different types of equation. As you know, we have linear equations, we have quadratic equation, we have simultaneous equation, and so on like that. But today, we are going to be looking at quadratic. And what, from the name given, quadratic means the polynomial of degree 2. What do I mean by this? So if you say polynomial of degree 2, the general form of polynomial is given as as squared plus bs, or you can say as raised to power n plus bs raised to power n minus 1 plus cs n raised to power s raised to power n minus 2 plus dot 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 plus the constant, let's say e equals to 0. So this is the general form of quadratic, the general polynomial. But the general form of quadratic equation, as we know that quadratic equation is any equation of degree 2. Degree 2 in the sense that the highest power of unknown is 2. That is for quadratic equation. But if we are to be linear equation, the highest power of degree under linear equation is 1. And mind you, under linear equation, we are going to have 1 as our answer for linear equation. But for quadratic equation, we are going to have two set of solutions. That is 2 answers under quadratic equation. So that will give us the brief explanation of the topic. So let me go by writing the general form. So the general form of quadratic equation is as squared plus bs plus c equals to 0. So this is the general form of quadratic equation, and we call it polynomial of degree 2. So where a, b, and c are constant. So constant in the sense that a, b, and c are given numbers. So it can be any number. But mind you, a must not be equal to 0. So for this condition to hold, that is the condition for quadratic equation to hold, a must not be equal to 0. Because if a is equal to 0, this equation given here will not be quadratic equation anymore. So it will change to linear equation. That is, if you have as squared plus bs plus c equals 0. So if a equals to 0, what will happen? We are going to have 0 multiplied by s squared plus bs plus c equals 0. So we have everything here is 0. So we have bs plus c equals 0. So bs plus c equals 0 is linear equation. So in this case, a must not be equal to 0 for quadratic equation to hold under this general form of quadratic equation. So a, b, and c are constant. Then under quadratic equation, the type of answer we are going to have 2 answers because of the degree here. So the degree of the unknown will tell us the number of answer we are going to have for that equation. So let's say you have equation of degree 3 like as raised to power 3 plus bs squared plus cs plus d equals 0. In this case, we are going to have 3 sets of answers because the highest power of unknown is 3. So definitely we are going to have 3 sets of answers in this cubic equation. We call it cubic equation. That is as raised to power 3 plus bs squared plus cs plus d. So we are going to have 3 sets of answers. So for quadratic equation, we are going to have only 2 sets of solution. That is for quadratic. Then e.g., now the example given, one of the example of quadratic equation is, so let me give you the first one, 4s raised to power 2 plus 3s plus 5 equals to 0. So in this case, a equals to 4, b equals to 3, and c equals to 5. So this is a good example of quadratic equation. Then another form of quadratic equation is, let's say 2s squared minus 3 equals to 0. So this is another form of quadratic equation. So in this case, if you compare this equation with the general form of equation, a will be equal to what? A is 2. B is 0 because we don't have any term for bx. So the b there is 0. 0 multiplied by x is 0. So we don't have the second term, which is bs. Then the constant, that is the number without x, that's c equals to minus 3. So this is another form of quadratic equation. Then we still have another one, number 3. Let's say s into s plus 5 equals to 0. This is another form of quadratic equation. Or we say minus 5. So this is another form of quadratic equation. In this case, if you open the bracket, we are going to have s times s, that's s squared, s times minus 5x equals to 0. So in this case, a equals to 1, b equals to minus 5, then c will be equal to what? 0. So, and so on like this. So these are examples of quadratic equation and so on. So these are examples of quadratic equation. So as we know, the general form of quadratic equation is as squared plus bs plus c, where a, b, and c are constant. Where a, b, and c are constant. But, where a, b, and c are constant, and a must not be equal to 0. What will happen if a is equal to 0? It means the quadratic equation will become linear equation. So it will, it will not be linear quadratic equation anymore. Then example of quadratic equations are 4s squared plus bs plus 5 equals to 0, where a equals to 4, b equals to 3, and c equals to 5. If you compare the equation with the general form of equation of quadratic equation. Then the second form of the equation given is 2s squared minus 3 equals to 0, where a equals to 5, b equals to 0. We don't have a term for bx, because b there is 0. Then 0 multiplied by x is 0. We don't have the second term. Then the constant is minus 3. That is the number without x. Then the third one, we have x into bracket s minus 5 equals 0. So if you open the bracket, we have s times s squared, s times minus 5s equals to 0. So in this case, the coefficient of s squared, which is a from the general form of quadratic equation, is 1. B is minus 5, that is the coefficient of x, where c is what? Is 0. So this just a brief explanation and example on quadratic equation. So the third objective, that is the derivation of quadratic equation from given root. I've told you, under quadratic equation, we are going to have 2 sets of answers. But under derivation of quadratic equation, so we want to use the solution to get the equation of, to get the quadratic equation. So before we do that, I'm going to prove how to derive quadratic equation from two given roots. So let A and A. So the next thing to do is to prove or to derive an equation on how to get the quadratic equation from given roots. And to do that, we are going to let A and B be the roots of the quadratic equation. So I've told you we are going to have two answers. So let the set of two answers be A and B of the quadratic equation with the unknown variable x. So that's why we have this x. If it is unknown variable y, so we are going to have y equals to. So now x equals to A or x equals to B. So let's assume these are the set of answers for the quadratic equation we are about to derive. Then the next thing to do is to write zeros of s equals to A and write zero of s equals to B. So we now have s minus A equals to 0 or x minus B equals to 0. So if each of these is equal to 0, their product will definitely be equal to 0. So we now multiply the two expressions. So we have s minus A multiplied by x minus B, which is equal to 0. So the next thing to do is to open the bracket. So we use each of the term in the first bracket to multiply the second bracket. So we have x from the first bracket multiplied by the second bracket, s minus B. Then use the second term from the first bracket, that is minus A, to multiply the second bracket, s minus B, equal 0. So you now open the bracket. So s multiplied by x, that's s squared, minus s multiplied by b, bx, minus a times x, that's minus ax, minus times minus plus a times b, equals to 0. So the next thing to do is to rearrange. So we have s squared minus ax minus bx plus ab equals 0. So the next thing to do is to factor out the common factor here. So we have s squared, minus is common, then bring minus out. X is common, we have minus x into a, extract minus from minus, we have plus, then plus b, then plus ab equals to 0. So you can now bring this s before the bracket, take it to the back here. So we now have it as s squared minus bracket upon a plus b, x plus ab equals 0. So this is the quadratic equation from these two given roots. So you can now write it as s squared minus a plus b, that is the sum of the roots. So it's now going to be sum of roots x plus ab is what? That is a times b. We have ab. That is the product. We now have product of roots equals to 0. So what we are saying is, for you to get a quadratic equation from two given roots, the first thing to do, look for the sum of the roots, look for the product of the root, and substitute it into this formula. You will get the equation, the quadratic equation that owns that set of solutions. So this is the proof of how to derive quadratic equation from given root. So the next thing to do is to move to the example. So let's take this as example. Examples 1. So derive the quadratic equation whose roots are 2 and 3. So this is the first example. So the question says, derive the quadratic equation whose roots are 2 and 3. So here, the first thing to do is to represent the solution. So represent the first root as a. So a equals to, or you say let a equals to 2 and b equals to 3. So the first thing to do, now look for the sum of the root. So what will be the sum of the root? That is a plus b. The sum, which is a plus b equals to 2 plus 3. And what is 2 plus 3? 5. So that is sum of the root. Then product of the root equals to ab. So ab means a times b. That is 2 times 3. And what is 2 times 3? 6. So you now substitute this and this into the formula. And the formula is s squared. If the unknown variable is x, so s squared minus sum of root x plus product of root equal to 0. So we now have s squared minus, what is sum of the root? 5. So 5 into x plus product of root 6 equals to 0. So we now have s squared minus 5 times x, 5x, then plus 6 equal 0. So the equation that owns 2 and 3 as its root is equal to what? S squared minus 5s plus 6 equals to 0. This is how to derive quadratic equation from given root. So let me go to example 2. So the second question is construct a quadratic equation whose roots are minus 2 whole number, 1 over 4, and minus 1. So instead of derive, they can as well use construct. It's still the same thing. So construct a quadratic equation whose roots are this and this. So solution, let a equals to minus 2 whole number 1 over 4, which is mixed number. We are going to change it to what? Improper fraction. So which is equals to 4 times minus 2, that's minus 8, plus 1, that's minus 9 all over 4. So that is our A. Then P equals to what? Minus 1. So the next thing to do is to look for the sum of the root and the product of the root. So sum of the root will be A plus B, which is minus 9 over 4 plus minus 1. So which is equals to minus 9 over 4 minus 1 over 1. Then we find the LCM. So LCM of 4 and 1 is 4. 4 and 4, 1. 1 times minus 9, then minus 1 and 4, 4. 4 times 1, 4. So we now have minus 13 over 4. That is for the sum of the root. Then the product of the root, we have A, B. And what is our A? Minus 9 over 4 multiplied by minus 1. So minus times minus plus 9 over 4 times 1, 9 over 4. So you now put the sum and product of the root into the formula. And what's the formula? The formula is, we are still using the unknown variable x. So we have s squared minus sum of root, or you can say a plus b into x, then plus ab equal 0. So that's the formula to use to derive the quadratic equation or to construct the quadratic equation. So we have s squared minus, so what is the sum of the root? Sum of the root is minus 13 over 4. So minus 13 over 4 x plus ab is 9 over 4. So we have 9 over 4 equal 0. So the next thing to do is to open the bracket and simplify. So s squared minus times minus is plus. Then we have 13. 13 times x, that's 13x all over 4 plus 9 over 4 equal 0. So it is not proper to leave our answer in fraction. So we are going to clear the denominator by multiplying through by 4, or you take the LCM. So you can do it in either way. So the LCM of 1, 4, and 4 is 4. So 1 and 4, 4. 4 times s squared, that's 4s squared. plus 4 in 4, 1. 1 times 13x, 13x plus 4 in 4, 1. 1 times 9, 9 equals to 0 over 1. The 0 over 1 is still 0. That's why we have it as 0 over 1. Then you now cross multiply. So if you cross multiply, all the numerator here will multiply 1, it still be the same thing. So 4x squared plus 13x plus 9 equals to 4 multiplied by 0 is 0. So the equation that on minus 2 whole number 1 over 4 and minus 1 as its root is 4x squared plus 13x plus 9 equals to 0. So this is how to derive or how to construct a quadratic equation from given roots. So roots of quadratic equation is always the solution to that quadratic equation. So another name for root is also known as solution. So that is that on question 2. So let me give you example 3. Example 3. So question 3, we a little bit use another method apart from the one I've been using. So the question says find the equation whose roots are minus 2 over 3 and minus 1 over 4. So we can as well use another method. And we are going to get that from, let's say the unknown variable is x. So you can now say x equals to what? X equals to minus 2 over 3 or x equals minus 1 over 4. So if you have it like this, it means the two solutions for quadratic equation we are about to derive are this and this. Then we now write zeros of this. Just write zeros of this and the product. So it will now be x. You take the x, then you transfer minus 2 over 3 up to this, to this side. So the minus here will change to plus. So plus 2 over 3, close the bracket. Then the second solution, which is x, the minus also change to what? Plus. Assuming it is plus, it will change to minus. But since we have it as minus, it will change to plus. So we have 1 over 4 equals to 0. So you now open the bracket. So to open the bracket, it's going to be x multiplied by x, that's x squared. So x multiplied by x, we have x squared. Then x multiplied by 1 over 4, we have plus x over 4. Then 2 over 3 multiplied by x, that is plus 2x over 3. Then 2 over 3 multiplied by 1 over 4. So we have plus 2 over 3 multiplied by 1 over 4 equals to 0. So let's now simplify further. We have x squared plus SCM. As you can see, we have x here, we have x here. So they are the like terms. Just look for the SCM of these two. SCM is 12. 4 in 12, 3. 3 times x, 3x. Plus 3 in 12, 4. 4 times 2x, that's 8x. Then plus 2 times 1, 2. All over 3 times 4, 12. Equals to 0. Then we now have x squared plus 3 plus 8, that's 11x. All over 12 plus 2 over 12 equals to 0. So find the LCM. LCM of 1, 12, and 12 is 12. 1 in 12, 12, 12 times x squared, that's 12x squared, plus 12 in 12, 1 times 11x, that's 11x, plus 12 in 12, 1 times 2, 2, equals to 0 over 1. Then you cross multiply. If you cross multiply, all the numerator here, we multiply 1, thus we have it as 12x squared plus 11x plus 2 equals to 12 multiplied by 0, that is 0. So the answer to this, the equation whose roots are this and this is 12x squared plus 11x plus 2. So let me now use the first method. whether we are going to have or we are going to arrive at the same answer. And what's the first method? The first method is to look for sum and product of root. So, or if you don't want to use the first method here, so let me bring the second method. And the root of quadratic equation are minus 2 over 3 and minus 1 over 4. So let A equals to minus 2 over 3 and B equals to minus 1 over 4. Then sum of root, that is A plus B, equals to minus 2 over 3 plus minus 1 over 4, which is minus 2 over 3 minus 1 over 4. So LCM is 12. 3 in 12, 4 times minus 2, minus 8, minus 4 in 12, 3 times 1, 3. So we have minus 11 over 12. So that's the sum of the root. Then product of the root, AB equals to minus 2 over 3 multiplied by minus 1 over 4, which is equals to minus times minus plus 2 times 1, 2, 3 times 4, 12. So if you like to reduce it to the lowest term, we are still going to arrive at the same answer. Then what is the equation? The equation is S squared minus sum of root, that is A plus B S plus AB equals to 0. So which is S squared minus, what is A plus B? That's minus 11 over 12 X plus AB 2 over 12 equals 0. So we have S squared minus times minus plus, that's 11x over 12 plus 11x over 12 plus 2 over 12 equals to 0. So multiply through by 12. So this will become 12s squared plus 11s over 12 multiplied by 12. 12 will call 12, you will be left with 11x plus 2 over 12 multiplied by 12. So just like this, multiply through by 12, multiply through by 12, multiply through by 12. So 12 multiplied by s squared, 12s squared, 12 multiplied by 11s over 12, 12 equals 12, we'll be left with 11x. 12 multiplied by 2 over 12, 12 equals 12, we'll be left with 2. Then equals to 12 multiplied by 0 is 0. So if you compare this answer with this answer, you can see they are the same. So either of the two methods is allowed in the exam. So thank you and God bless. So if you find this video interesting, please subscribe to the channel and give us a thumb up. Thank you.